Ukraine turned the wind into a weapon. Russia's billion-dollar air defense network is helpless against something. Radars can't see it, missiles can't catch it, electronic warfare systems can't disrupt it, and this thing doesn't even use an engine. The worst part? Russia can't copy it. Because the prevailing winds in the region blow in only one direction, from Ukraine toward Russia. Physics picked a side. The system Ukraine developed using the physical conditions in the region is simple but ingenious. A kamikaze drone attached to a helium balloon is sent into enemy airspace using the carrying power of the wind. The foundations of this system were laid starting in 2024. Balloons were first used for deception and reconnaissance, then as bomb carriers. But in May 2026, they took the most radical step in this evolution. They tested launching a kamikaze drone from a balloon, and the results exceeded expectations. The balloon picked up a Hornet kamikaze drone from the ground and carried it 42 kilometers with the wind, without using an engine, without burning fuel, without touching the battery. Those 42 kilometers are entirely free because the atmosphere does all the work. The balloon also lifted the drone to 8 kilometers altitude, and this height created a second advantage. When released, the drone could glide a significant distance without engaging its motor. A ground-launched drone spends its first few kilometers climbing and burns through its battery. A balloon-launched drone doesn't spend that energy at all. It reaches the release point with 95% of its battery intact, nearly full charge. The result is clear. The Hornet's standard range is approximately 150 kilometers. With the balloon combination, this range extends to 300 kilometers. Free transport, free altitude, and preserved battery stack three separate advantages on top of each other and double the range. The figure has not yet been independently verified, but test results were shared by Ukrainian sources. The Hornet is a fixed-wing kamikaze drone manufactured by the US-based company Perennial Autonomy, gliding silently on wings spanning nearly 2 meters, carrying a 5-kilogram warhead to its target at approximately 100 kilometers per hour. But what makes it truly dangerous isn't speed or payload. It's the AI-powered guidance system. When electronic warfare jamming cuts the signal, the drone doesn't stop. It reaches the target on its own using preloaded terrain contours. Russian electronic warfare operators describe it in their own reports as extremely dangerous, because when they cut the signal, the AI takes over and strikes. Ukraine is developing new launch systems to make this drone even more lethal, and the Aerostat combination is the most radical of them. Doubling the range of a weapon already capable of operating 160 kilometers deep eliminates the concept of a safe zone behind the front entirely. But what makes this system truly devastating isn't the technology, it's the geography. More precisely, the atmosphere. Ukraine is positioned in the mid-latitudes of the northern hemisphere, between 45 and 52 degrees. At these latitudes, the atmosphere has a fundamental rule. Prevailing winds flow from west to east, and these westerly winds blow from Ukrainian territory toward Russian territory, continuously, permanently, and unchangeably. When Ukraine releases a balloon, the atmosphere carries it eastward, toward Russia. No engine needed, no fuel burned, no energy consumed. Nature itself serves as the carrier. And this is exactly where Russia's real problem begins. Instead of blowing from Russia toward Ukraine, the same wind blows from Russia further east, toward Siberia, toward Kazakhstan. If Russia wanted to reverse this system, it would need to redesign the fundamental dynamics of the atmosphere. Retired Colonel Viktor Kevliuk, analyst at the Center for Defense Strategies of the Ukrainian Defense Forces, sums it up in one sentence. The Russians also have aerostats, but in this domain, the atmosphere is not in their favor. Wind dependence naturally raises a question. Can you fully control the balloons? Short answer, no. But modern meteorology has transformed this into a solvable equation. AI models and advanced algorithms can predict wind trajectories with operational accuracy. Balloons can be launched from anywhere, and a skilled team can complete the entire process from setup to launch in 15 minutes. Once they rise above 10 kilometers, they're largely unaffected by adverse weather conditions. The wind is more stable, turbulence is lower, and the range limit is far wider than you'd think. On a single mission, a Ukrainian balloon traveled more than 4,000 kilometers over Russia. The wind carries for free, and it never tires. But free-flying balloons are only one dimension of this system. Ukraine is also using tethered aerostats, platforms that hover in place, draw their electricity from the cable, and can stay airborne for up to 3 days. These systems, manufactured by the Aeroba company, are positioned at 500 to 1,000 meters altitude and perform multiple critical tasks simultaneously. As powerful communication relays, they enable control of FPV drones and medium-range strike drones from hundreds of kilometers away. With their cameras and sensors, they conduct reconnaissance and surveillance, detecting Shahed drones and other aerial threats. And signal repeaters exceeding 100 kilometers can be chained together, creating a continuous control link for long-range weapons. To date, only 2 of these systems have been confirmed destroyed, meaning their survival rates are remarkably high. Free-flying balloons carry on the wind. Tethered aerostats provide control. Together they form the invisible backbone of Ukraine's aerial ecosystem. We mentioned earlier that Ukraine has been using balloons since 2024, evolving from deception to bomb carrier, and from there to drone launch platform. Now let's look closely at each stage of this evolution, because the transformation that occurred over 2 years is critical to understanding the course of the war. In 2024, the first balloons were launched for reconnaissance and deception, creating false targets on radars to distract Russian air defenses. Simple, cheap, limited. But it worked. From the fall of 2025 onward, operations grew rapidly. Ukrainian forces released more than 1,000 helium balloons into Russia, and this time the payloads diversified. Not just decoys, but signal repeaters, reconnaissance equipment, bombs, and small attack drones began to be carried. In the September 2025 major drone attacks targeting Moscow and Tatarstan, balloons were used extensively. Russian sources stated they saw numerous balloons, and that these had deceived their radars. Refineries, railways, and deep rear logistics centers were targeted. By late 2025, balloons entered service as bomb carriers. Direct explosive payload delivery capability was added. And in May 2026, the launch of a Hornet Kamikaze drone from an Aerostat was tested. From decoy to reconnaissance, from reconnaissance to bomb carrier, from bomb carrier to drone launch platform. At each stage, the balloon became smarter, more lethal, and cheaper. The analysis group Tochny documented the concrete impact of this evolution. Between February and March 2026, medium-range drone strikes more than doubled, reaching at least 288 raids. Among the targets were Russian resupply depots, logistics vehicles, electrical infrastructure, and rear-area air defense systems. Balloon-supported operations were the primary accelerator of this increase. And the Hornet plus Aerostat test is the latest link in this evolution, but probably not the last. The numbers tell the story of this war, and the numbers are working against Russia. The balloon itself is made from latex, nylon, or polyethylene, all simple industrial materials, all sourced entirely within Ukraine. No dependence on China, no import bottleneck. Helium filling isn't as expensive as you'd expect either, because aerostats don't require high-purity helium. Industrial grade is sufficient. The Iran-Israel conflict may have affected production in Qatar, but a source confirms this hasn't disrupted operations, and sufficient helium remains available. The Hornet drone's unit cost varies between $5,000 and $12,000, depending on configuration. When you calculate the balloon and drone together, the total system starts at approximately $6,000. The daily operating cost of tethered aerostats, according to Kevliuk's estimate, is $15. Now place these figures alongside Russia's defense spending. A single Pantsir S-1 missile costs between $60,000 and $100,000. An S-300 missile can reach up to $500,000. The S-400's 48N6 missile exceeds $1 million. And these missiles are being fired to shoot down a balloon costing a few $100s, sometimes multiple missiles at the same balloon. Kevliuk clarifies the equation. This technology is emerging as an asymmetric response, cheap and effective for unmanned aerial vehicle warfare. But cost asymmetry isn't limited to unit price. The indirect costs are far more devastating. Every balloon forces Russia's air defense to stay active. Radars constantly on, personnel constantly on alert, missiles constantly ready. The electricity consumption, personnel fatigue, and equipment wear of this perpetual alert state costs thousands of times more than a single balloon. And Ukraine is launching thousands of balloons. Russia has to spend resources on each one individually. The math can't be reversed. Moreover, Russia's response to this system is deepening the problem rather than solving it. The problem begins with altitude. When balloons rise above 10 kilometers, the altitude ceiling of short-range systems like the Pantsir and Tor can't reach them. At this point, Russia is forced to engage strategic air defense systems like the S-300 and S-400, firing missiles worth millions of dollars to bring down a balloon worth a few hundred. This alone is a bad enough equation, but the real problem runs deeper. Because some of the balloons are designed to be detected on purpose. It sounds contradictory, but the strategic logic is very clear. A source close to operations states it openly. You want to be detected. They cause panic for the Russians, and they're very difficult to shoot down at high altitudes, which leads the Russians to waste their air defenses. In other words, decoy balloons occupy Russian radars and missile batteries, while the real attack drones reach their targets silently along a different route. This situation leaves Russia facing an unsolvable dilemma. When a balloon appears on his radar, a commander is trapped between two choices. If he fires, he spent a missile worth millions of dollars on a balloon worth a few hundred, and that missile is no longer available against the real drone wave coming along a different route minutes later. If he doesn't fire, the balloon might be carrying a real weapon, and a few hours later, a refinery is burning. Whatever decision he makes, he pays a price. Moscow experienced the most striking example of this dilemma. Balloons approaching the capital caused temporary airport closures. Civilian flights were suspended. Air traffic control was paralyzed. A source confirms this reaction. If you approach a sensitive area like Moscow, they get very scared and fire without hesitation. Every time they fire, what Ukraine wants happens. An expensive missile is spent, a radar position is exposed, air defense capacity erodes a little more. The cumulative effect of this process can be called air defense fatigue. When radars are kept continuously active, personnel get tired, attention inevitably wanders, and equipment wears down much faster than normal. When the real drone wave arrives, a coordinated attack of dozens or hundreds of kamikaze drones, the air defense system is already exhausted. Missile stocks have dwindled, operators are experiencing alert fatigue, response times have lengthened. Ukraine's cheap balloons are rotting Russia's expensive defenses from the inside. And Russia isn't the first country unable to find this formula. Russia's army isn't the first to try defending against a weapon carried by the wind. In 1944, Japan released more than 9,000 Fugo balloon bombs into the Pacific jet stream. Target: the American mainland. The balloons crossed the Pacific Ocean on the wind, covering 8,000 kilometers without engines, without fuel, without pilots. The United States hid the existence of this weapon from the public. It imposed censorship because the panic itself was more dangerous than the weapon. Japan, thanks to the censorship, never learned that the balloons had reached the US. It continued and eventually abandoned the program without knowing whether the attacks had worked. 80 years later, Ukraine is applying the same principle at an entirely different level. Japan had only balloons and explosives, no targeting, no control. Most balloons fell into the ocean. Ukraine has AI-powered kamikaze drones, meteorological modeling, autonomous target classification, and real-time terrain contour guidance. The same physics principle, the carrying power of the wind, but with 80 years of technological accumulation layered on top. The US couldn't find a solution to this weapon in 1944. It suppressed it with censorship. Russia in 2026 faces a far more advanced version of the same weapon, and doesn't even have the option of censorship. But Ukraine's advantage isn't limitless either. The wind advantage is real and permanent, but not limitless. The system's most fundamental constraint is the control problem. Once the balloon is surrendered to the wind, the operator can't steer it. AI meteorology models can predict wind trajectories, but the atmosphere is a chaotic system, and significant margins of error are unavoidable on every mission. When the wind changes direction unexpectedly, the balloon drifts off target. In poor weather conditions, the launch window narrows or closes entirely. You don't have the luxury of using this weapon whenever you want. You wait for the window nature permits. As altitude increases, a different problem emerges. GPS reliability drops. At high altitudes, the balloon begins receiving interference and spoofed signal waves from a very wide area, making precise guidance of the drone difficult. Russia's electronic warfare operators are targeting exactly this weakness. intensifying signal jamming, and GPS spoofing to make drones veer off target. Ukraine's AI-powered terrain contour guidance offers a partial solution to this problem, but claiming 100% reliability under all conditions isn't realistic yet. And perhaps the most important point, the Hornet and Aerostat combination is currently in the testing phase. The May 2026 trial produced successful results, but an operational attack carried out with this system has not yet been confirmed. The 300-kilometer range claim has not been independently verified. The potential is large but unproven. Ignoring the difference would be a mistake. That said, these limitations don't eliminate the system's strategic value, because this weapon's power comes not from its precision, but from its cost asymmetry. A source close to operations puts it pragmatically. There may be problems, but it's better than not having the Aerostat. Even if only 10 out of 100 balloons reach their target, Ukraine has spent a few $1,000s, while Russia has fired tens or hundreds of thousands of dollars worth of missiles at each balloon. The math doesn't require perfection. Consistency is enough. And every new test cycle, every new AI update makes the system a little more reliable. The technology isn't static, it's evolving. Let's zoom out and look at the big picture. There's a pattern in Ukraine's wartime innovation. Progression toward cheaper, simpler, more scalable solutions at every stage. They moved from expensive missiles to cheap kamikaze drones, from cheap drones to free wind. At every step, the cost asymmetry grew against Russia. This isn't just a balloon, it's the evolution map of the war. The traditional defense industry produces platforms worth billions of dollars. Ukraine is achieving the same effect with systems worth a few thousand, and the wind is paying the bill. Balloons don't just carry drones either. They can also carry unmanned ground vehicles and unmanned surface vessels. A source close to operations draws a provocative future projection. Imagine a Ukrainian UGV in Red Square. Balloons from the sky, drones from the air, unmanned vessels from the sea, unmanned vehicles from the ground. A multi-dimensional unmanned attack ecosystem. And they all share one trait: cheap, autonomous, scalable. Kevliuk has the final word. The trend is clear. Balloons have become part of the arsenal for medium and deep-range strikes. Ukraine was dragged into a full-scale war with many disadvantages, but it has begun capitalizing on an advantage that nature itself bestowed. The prevailing wind doesn't change. Physics picked a side, and it's not switching. We'll continue tracking developments on this front with our analysis. Subscribe to the Geo Network, and thank you for watching. One last reminder. If you want the analysis to keep going even after you close the screen, we're also on Spotify, turning long drives into briefings. We'll be waiting for you there too.